In this lecture, we will learn binary search. We completed about vectors. We also saw how the internal vector works in the C++ library that is known as the standard template library. Now let's do an algorithmic concept called the binary search. What is binary search? It is used to find the occurrence of a value in a monotonic array. And why is monotonic written like that? Monotonic is written like that to tell you that what monotonic means. Monotonic means having one sort of direction. So it is either rising, either falling, or staying constant. So having a fixed direction at every point, having a fixed direction of movement in every point is known as monotonicity. And this is the concept that we will use in binary search. For those of you who know about binary search, you might have used it on sorted arrays, either ascendingly sorted or descendingly sorted. But let me tell you, binary search is not limited to arrays. They can be performed on different kind of functions and also in different kind of problems where seeing binary search in the first go is a little bit difficult. We'll discuss them slowly, but let's first see the normal sorted array binary search. So what happens in a binary search is you need to find a given value in a given array and you need three pointers for this. The first pointer is at the starting of the array and the second pointer is at the ending of the array. The third pointer is calculated on the basis of these two pointers and it is the middle of both these pointers. And now you look at this position, the third pointer, and make a judgment. So let's say you had to make a judgment on this mountain that so you had to make a judgment on this ramp that where this thread was. Now you know that this slope has a little bit of value. Now when you reach here, you realize that you actually have to move ahead. Now you reach here where you realize, no, I have to move a little bit backward. And this is how you have to iterate. When you go at a point, you actually realize that the rest of the peak, the rest of the mountain is useless. A part of the mountain becomes useless. Let's see. Let's think of an example. Let's say you were looking for a name in the dictionary and you opened it and saw that the name that you so let's say you were looking for a name that looks like let's say Jack, and you found a name that looks like, let's say, uh, a name that looks like Drake. You won't look at the names that are behind Drake because they will all be starting from D, C, B, and A. And let's say you find a different name ahead. Let's say you find a different name called Zach in the end, not Jack. You find Zach, and you know that you'll not be looking ahead of that because all the names are sorted. So the requirement of this binary search is that the array or the search space is sorted. Now let's see it's working. Let's say we were looking for 81 in this array. So you find the middle to be at 19 and then you realize that 19 is actually smaller, so we need to look in its right half. So you move this first pointer ahead to the 19 position and recalculate the position of the mid. And now you check the mid and you found the number that you were looking for. And this has a time complexity of an order of log n. And now since you've understood the basics, let's just code the basic binary search first and then we'll give you three tasks. One very simple one, the second one a little more complex, and a third one which is the introduction to the competitive programming world of binary search, aggressive chaos problem. See you in the next lecture.